Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lessons, I spent quite a bit of time talking about classes because they are so integral to .NET. In fact, just about everything in .NET somehow involves a class. And we talked about how the .NET Framework class library is just a collection of classes, some related to each other through inheritance, and you leverage all the code in the library to do cool stuff and not have to worry about writing all that code on your own. Microsoft has already spent literally tens of thousands of man hours writing code, and you can just borrow from it. And that was really the purpose of learning more about classes and inheritance and so on in the previous lessons. But because I really want you to understand how the .NET Framework class library was put together and how it works, and most importantly, how you can get the most out of it, I want to talk about one final topic related to all this, and that is to better understand how the code is organized and how to access code that just isn't added to your project by default. So in this lesson, we're going to talk about namespaces, we're going to talk about assemblies, and we'll talk about adding references to external assemblies using the IDE. So first of all, within the .NET Framework base class library, all the classes are organized in namespaces. You can think of a namespace as a last name for your classes. So my first name is Bob, but there are literally hundreds, if not thousands, of Bobs just in the town I live in. If somebody were to say Bob likes coffee, you might ask, which Bob are you talking about? Because there's like 10 million Bobs in the world, right? If they reply with my full name, Robert Theron Tabor, well, now you should have a pretty good idea who they're talking about. I'm pretty sure that the combination of my first, middle, and last name are relatively unique, so that might identify just one person in the entire world. Well, the same is true with classes in the .NET Framework class library. With tens of thousands of classes in the library, it's possible that a single name is shared by more than just one class. However, by using the namespace of the class, it removes the ambiguity. So while you might know which version of the class that you intended to use, the Visual Basic compiler, as it tries to make sense of your code, as it parses through it to ultimately create an executable file, it tries to resolve the reference to each class that you make inside of your code. And we saw a few lessons ago when we typed in the word stream reader, the IDE lets us know that it didn't recognize that class name, but it did give us some options as to which namespace that we might be referring to. So when the compiler is confused, it stops immediately and it forces you to explain further what you meant, and we call that a compilation error. So to set up this example, you should be able to download the code associated with this video from wherever you downloaded or from wherever you're streaming this video right now. And so you can see I have that folder copied to my desktop, and I'm just going to go in and grab everything in the before folder. That's both this namespaces and referencing assemblies folder and this tabor.dll, which we'll use as well. And I'm just going to copy those and put them into the folder that your version and edition of Visual Studio uses to save its projects. So in my case, I'm going to look in the Visual Studio 2010 subfolder of my documents directory and then go into the projects directory. Chances are you'll be using a different version or edition of Visual Studio, so just look for the place wherever it stores the projects. I'm just going to paste in both the tabor.dll file and the namespaces and referencing assemblies folder. I'm going to double click into that folder and then double click the solution file to open up that project in Visual Studio. Okay, and so the project itself, there's nothing all that special about. I haven't written any code in it just yet, but I wanted to make sure that you also got that DLL file, which we're going to use in a little while. But to start off with, if you needed to reference a class within your code, you could just use the entire name of the class, including its namespace, like this. Okay, so first of all, notice that I have an error here. That's because I didn't pass in anything into this, the constructor of the stream reader. Let's just ignore that for the moment. All right, first of all, you'll notice that there's this little blue squiggly line, and that appears because we need to give our new stream reader the constructor a file name. And just to satisfy that, I'm going to go ahead and put empty double quotes inside of the constructor, and now our blue squiggly line goes away, but this line of code will not work. What we really want to focus on is the full name of this class and kind of break it apart. So starting with system, this is a top level namespace that many other namespaces and classes belong to. Next up is the IO namespace, and this contains classes that deal with in and out, or rather getting data into and out of the application. And then finally we have the class itself, the stream reader. So you might be thinking to yourself, okay, how in the world am I going to memorize all of that stuff? How am I supposed to memorize all of the classes and namespaces for every class in the .NET Framework class library? That seems like a Herculean task. Unfortunately, you really don't have to do that. Most developers know that they want to work with the stream reader class. They may not remember which namespace it belongs to, and there's a shortcut. I think I already demonstrated this once that'll show you, that will help you resolve that. And then also, you don't even have to type in all of this information. Most developers rely on import statements to shorten the amount of code that they have to write. So they might do something like this. I'm just going to highlight system.io, hit Control X on the keyboard, get rid of that, and then go up to the very top of the file and paste in system.io. So now I can just do imports system.io. So an import statement provides access to all of the other namespaces or classes that belong to it, so you don't have to type it all out. You're basically telling the compiler, hey, I'm using this namespace. So before you complain about not being able to resolve a class name and find its full name, please check these namespaces first to ensure that the class I'm referencing in my code actually belongs to one of them. And so in Visual Basic, there are two ways to import a namespace. The import statement like you see here, and then there's also a way through the properties pages. So if you were to right click on the property and select properties from the context menu, then you'll see on the left hand side a tab called references. At the top of this tab there is a list of actual assemblies that are referenced in our code. And assemblies are the files that contain the code. And so by referencing them, we're telling Visual Basic to make that code available to our project. And below that is this area of imported namespaces. And these refer to the namespaces of the code inside of our assemblies. And this is basically a shortcut to using the imports keyword. You can see a number of them have a check mark next to them, while a number of them below do not. So we have not imported those. Now we could remove our imports system.io by just clicking this, checking this checkbox next to system.io, and I could remove this and we should get the same results. No blue squiggly line under stream reader. Alright, so those two ways of doing the exact same thing. So back to the properties. Why are some assemblies and namespaces already referenced and imported? Well, the project template, whenever we go to File, New Project, and select Console Application, that project template adds these as a convenience so that you don't have to add them yourself. Now you can remove some of these if you're confident that you won't need them, and you can add new ones to the list just like I did a moment ago. There's no reason to remove them as far as the compiler is concerned. It'll compile the code the same regardless of whether or not there are extra unused import statements or selections in this dialog. Some developers prefer to keep this list tidy so that they know when looking at the code exactly what's going on. Removing unused import statements helps them comprehend the code better. And you can decide if that's something that you prefer to do once you get more experience, but it's really not a necessary step. You can reference everything if you want to, although I really don't recommend that. Alright, so back to the code. Let's actually get rid of this and add our imports system.io. Alright, and now we're back to where we were a moment ago. Actually, let's do this. Let's go ahead and remove it. And let's retype this entire line of code. All right, so as I began to type StreamReader, IntelliSense didn't help us out because we didn't import the namespace into our project so far, so it doesn't even know that StreamReader is a possibility. In fact, as I go to the next line, you'll see that I get an error message that says type StreamReader is not defined. But as I pointed out earlier, we get this little smart tag that pops out underneath. It starts out as a little red cursor. As we hover our mouse cursor over it, it goes to a red exclamation icon, and as we drop it down, we can see that it gives us the option of importing system.io. So it did the heavy lifting of finding out the possibilities of what we actually meant and represented those and gave us a shortcut to actually add the import statement. Now there's one other thing that we can do here. I'm going to delete this one more time. We get that blue squiggly and the little dash, and I'm going to put my mouse cursor right next to the red dash, and suppose that I didn't want my hands to leave the keyboard, I can hold down the control period on the keyboard and the smart tag opens up. Now I can use the arrow keys up and down on my keyboard to the right of the keyboard to select this first option, import system.io, and then hit the enter key on the keyboard, and it will add the system.io to the import section of my file. Pretty cool. All right, so before we leave this idea, occasionally you'll attempt to use a class in the .NET Framework class library, but you'll get an error that says something about there being some ambiguity. The reason that you may have ambiguity is that you'll have two import statements that both happen to have a class with the same name in it. In that case, you merely have to type out the full namespace of the class in order to get it working again. Okay, just want you to be aware of that. All right, so before we close this discussion of namespaces, let me point out a couple of things. First of all, every time you create a new application, there's a default namespace already declared for you within Visual Basic. If you were to right-click again and go to the Properties context menu item, and you go back up to Application, notice that we have a root namespace called whatever the name of your project is by default. All right, so that means that whenever you create a new class, it will automatically have namespaces and referencing assemblies dot car or dot truck, for example. Okay, so there's always a root namespace that's automatically created for you, and you can take control of that by creating additional namespaces using the keyword namespace. Secondly, you can set the default namespace in the project properties by just changing its name. So my new name. All right. Now, while the technique is easy, I just demonstrated it, the reason why you might want to ever do this is a bit more advanced, and for the sake of keeping this topic simple, I'm going to encourage you to revisit this idea after you have more experience under your belt in software development. Okay? And third, likewise, you can create additional namespaces for your own code using the namespace keyword like I alluded to a moment ago. Again, that technique is really simple, but the reasons why you might choose to do this are rather advanced. So again, if you set out at some point in the future to build some large software application in an organization that utilizes namespaces, you will want to spend some time and really think about architecting your namespaces in such a way that it accurately represents the division of code and that you're aiming for. Okay, and that's all I'm going to say about that because, again, that's a little bit further down the line for you at this point. Okay, so the next important topic related to code organization is that in an effort to keep the .NET Framework class library manageable, they broke up all of those 10,000 or tens of thousands of classes into a few dozen physical files. And we saw this already when we went to the references here. Notice that all of these file names, system.dll, system.core.dll, system.data.dll, and so on, they all are part of the .NET Framework, and yet, and each of these have a bunch of different namespaces associated with them, each of those with dozens, if not hundreds of classes inside of them, but they split all of this up in an effort to keep everything organized. If you had to load up one monstrous assembly file with literally tens of thousands of classes, each with potentially hundreds of lines of code, most of which you'll never even use, every time you ran a .NET application, it would take up the entire computer's memory, and it would probably, as a result, be extremely slow. So instead, they put related functionality across many different namespaces into different assemblies. So when you create a new project, the template for that project, as we've seen already, includes references to several core assemblies like you're looking at right now. So what happens when you realize that you need a part of the .NET Framework class library that hasn't already been added to your project? Well, then you have to add a reference to that assembly. In fact, this isn't only true for assemblies that were created by Microsoft and part of the .NET Framework class library, but it's true of any third-party assembly that you want to use in your application, whether they're some commercial product or some open source library, or even libraries of business rules that are specific to your company or organization that one of your employees have created. You have to first add a reference to the assembly into the project so that when you reference the namespace and the class names, it'll know which files to look for in the actual code implementation. And so, since I want to keep things as simple as possible, I've already created a super simple library of my own called Tabor. We copied it into our projects directory as we started this lesson. And so my Tabor library has a single class called Bob, okay? It wasn't very original here. My Bob class has a single method called lookup, which accepts an input parameter of type string that represents a URL for a website. And then the lookup method will pull down all of the HTML for that web page from that URL. And so what we can do here to add a reference to that assembly is click Add, and I'm going to use the Browse tab on the Add Reference dialog. Now if I wanted to add another component or assembly from the .NET Framework class library, I could just go to this .NET tab. Or if there was a project that I was working on that ultimately will be compiled into assembly, I could just go to the Projects tab. But here I want to browse for an assembly somewhere on my hard drive. And so let me just kind of work my way through this. And so I'm going to go down, and it should have been pasted somewhere in the Projects directory. So I'm going to click tabor.dll and click OK. And we'll look at where it copies this in just a moment. You can see that the path is still tabor.dll in the projects directory, but that will change, I think, after we run this. All right, and so to use this in our application, let's go ahead and comment that out, and we'll just delete this. What I'm going to do is I'm going to go dim Bob as new Bob. And it will not find it. So let's see if our little trick will work. Control period. And what I can do is either change Bob to tabor.bob, and that seems to work, or I could just import Tabor, and that should work as well. All right, so now let's dim HTML as string equals bob.lookup, and then I'll pass in a URL to my website, www.learnvisualstudio.net. And then we'll just do a console.writeLine HTML, and then console.readLine. It looks like I spelled string wrong. There we go. All right, so let's run our application. And again, we didn't have to write the code required to go online to pull down all the HTML from my website's homepage. All I had to do was rely on that code that was created already in that tabor.dll assembly. That assembly contained a namespace called Tabor with a class called Bob, and that class had a single method called lookup. All right, so to recap, we learned how classes are organized into namespaces to help disambiguate class names, or rather to avoid class name collisions between two classes that are named exactly the same thing. We talked about the import statement that allows us to shorten the full name of a class by telling the compiler up front that it should first attempt to resolve all class names against those namespaces that we have imported or added into the import section at the very top of our code file. I also demonstrated how to use the IDE to help find namespaces for classes that we want to use within our application. We use that little, the smart tags, and we use that little neat trick of using Control period on our keyboard. We talked about the topic of how code is packaged into assemblies, and that when you create a new project from a template, part of the job of the template is to add references to commonly used assemblies. The .NET Framework class library is so large that it wouldn't make sense to add every reference to every single namespace and class all at once. However, if you need something from the library, you may need to add a reference to an external assembly. Additionally, many companies have created their own libraries of code, and you might need to use that if you go to work for them, and that those assemblies encapsulate the business logic necessary for a given area of the business. Also, there are third-party vendors as well as open source projects that provide libraries that you might want to use within your application. In all of these cases, you have to first add a reference to the assembly that contains the given code library that you want to utilize, like we did here. Okay, so next up we want to talk about all those mysterious public keywords that we've seen around our project. We'll talk about some other options as well, like private. We've ignored those up to now, but we'll also talk about things like scope and what's the difference between a module and a class exactly. We'll get to the bottom of that in the next lesson. We'll see you there. Thank you.